Interval partition is added in the version 11G to support to automatically create the partitions. Creating the partitions manually is a tedious task for the developer as well as the DBA. We cannot create the partitions on the fly. We can create the partitions during the downtime. That means we need to shut down the server, or we need to stop all the app servers. We should block all incoming requests from the business to the database server. Then we can add the partitions or split the partitions, or we can drop the table, create a new table with new partitions. We can do something else over there. The business will be affected during this time. So at some point of time we need to add the partitions, maybe after 3 months or after 1 year or after 5 years or 10 years. So we cannot create the partitions forever. We cannot create the partitions for 10 years or 20 years now. We can create the partitions. If it is yearly partition, maybe we can create the partitions for next 10 years. We cannot create for next 100 years or something. So at some point of time we need to create the partitions manually. So when we want to create the partitions, there should not be any data coming into this table from the business. The production must be stopped. The business should be stopped, or the incoming requests from the app server should be stopped sometime till the completion of our process. That is why Oracle has provided a solution for this. We can create the partitions automatically. Instead of creating the partitions manually, we can have partitions created automatically. That is what is the advantage of using interval partition. Using interval partition, we can create the partitions automatically as and when the data is inserted into the table. Basically, the table will be range partitioned based on the number column, date column, timestamp column, or time interval column. And we will be specifying a time interval over there, and then the partitions. So at least one partition we have to specify while creating the interval partition. We do not use the keyword partition by interval. We specify partition by range. Originally it's a range partitioned table, but we cannot use character data or any other column. We have to use either number, date, or timestamp or time interval. Only 4 data types are allowed for interval partition. So along with range partition, before specifying the partition name, we specify the time interval based on which the partition must be created, and then at least one base partition we define. Minimum of one partition is required for interval partition, otherwise it will throw an error. So in the first example, this is our normal table syntax. Partition by range of person ID, and then we specified interval 100. Next, partition P1, values less than 101. Table space is optional clause. Each partition can be placed in different table space. This is optional. We are using the default table space. We are getting the error, interval 100. This we don't want. So at interval 100 we are getting the error because the database is unable to understand what is this 100 seconds, minutes, days, weeks, years. We need to specify explicitly what is the time interval you are going to use for the partitions. So it has given error. Now let us see the next example, EMP part interval. We have columns We are doing range partition by range on created date, interval num to ym interval, year to month. Ym stands for year to month. Number to year to month interval. We are using one month. Monthly partitions we are creating. And then partition P_01, values less than 1st November 2007. Since we are passing a string value, we should convert this to date. So we are using toDate function. The values must be less than 1st November 2007. So in that case, whichever the date we insert before this date, all those dates will go into P01 partition. And whenever we create a new entry into the table with a new date, a new partition will be created if it is beyond this date. So if we insert 1st December 2007, new partition will be created. 1st Jan 2008, another partition will be created. Let us see how the partitions will be created now. Let us see as of now what are the partitions available. See, this is the table name we used. As of now, P01, one partition is there, number of rows 0, there is no data in the table. We are querying user tab partitions. This is the data dictionary view where the information about partitioned tables will be present. Table name, partition name, high value of the partition and number of rows in that partition. So high value for this partition is 2007-11-01. Number of rows 0 as of now. Let us insert data. We are inserting 16 October 2007, which is less than this. So it will go to the same partition. 31st October, it is less than 1st November. So 31st October is less than that. So both will go to the same partition, existing partition, current P01. So now if you query user tab partitions, it is giving 2 rows. Both the rows have come into the same partition. Insert another month. 1st November, even this is value less than 1st November. So even 1st November will go to the next partition. 30th November, new partition will be created. When we query user tab partitions, new partition is created, P44 sys_P44. There are 2 rows in that. The values will be less than 1st December 2007 in this partition. Insert 1st Jan 31st Jan 2008. Since it is monthly partition, this will go to another partition. A new partition will be created, P45. There are 2 records, that is less than 1st Feb. We can have one more partition in between. This is less than 1st December. This is less than 1st Feb. There should be one more partition between less than 1st Jan 2008. Since we did not insert that data, that partition has not created. Now we are inserting 1st December 2007, 31st December 2007. I think this is less than 1st December. Okay, one more partition will be created now. 4/6, this is less than 1st/01, that is less than 1st Jan 2008. But the partition is not in between, partition is the next partition. Partition names are not sequential. This is one drawback of interval partition. The partitions will be created as and when the new data is inserted into the table, but the partition names will be sequential. Partition names will not be in the proper order. So maintenance of the partitions becomes bit difficult. We cannot blindly truncate a partition, drop a partition by assuming this month's data will be present here like that. So we can assume that this is up to October, this is November, this is December, this is Jan, like that. But it is wrong. This is Jan and this is December. Because Jan month's data came first, December month's data came later, the names of the partitions are interchanged. So we cannot blindly assume based on the name of the partition. So we should actually see what type of data is there in that. And since the partitions are created automatically, we do not have any control on the name of the partition. So at some point of time, either we need to change the name of the partitions using rename option, so that we can give some meaningful name. Here we can give, instead of P01, we can give 2007 November or October. Next partition 2007 November, 2007 December, 2008 Jan. Like this we can give some meaningful names. Since the names are generated automatically by the database, we don't have any control here. So we still need a small maintenance here, changing the names of the partitions. At some point of time, if we change the name of the partitions, then the maintenance of the partitions becomes very easy for us. But anyway, it is very advantageous for us, very helpful for us. We need not bother to create new partitions, especially when we are creating daily partitions or hourly partitions, especially when we go into the share market, trading, online trading or online shopping, telecom domain. Every hour some crores of billions of data will be coming into the database. So in that case, we go for hourly partitioning sometimes. So in that case, every hour we need one partition. So every day we need 24 partitions. So every month 24 into 30, every year 24 into 30 into 12, this many partitions we require. So we don't bother what is the name of the partition. We need to store this data into a separate partition. So creating partitions become very risky, very difficult in this case. So that is where we can use interval partition, so that our hands will be free. So tension will be free for us. Next, reference partition. So we use reference partitioning between parent table and child table. The reference partition will be used for child table, so that whenever the parent table is partitioned, automatically the child table's column also will be partitioned accordingly as parent table. So to use reference partition, the parent table must be range partitioned. On the range partitioned on some column. See, here we are creating parent table, EMP part ref underscore P, range partition by range on created date. We are creating two partitions, P 2007 and P 2008. Values less than 1st Jan 2008, 1st Jan 2009. Means for 2007 one partition, for the year 2008 one more partition. Table is created. Creating the child table. So here PID we are making as foreign key, We have given a name for that. It is the referencing to parent table, ID column of parent table. Now for this child table we use partition by reference on foreign key name. The constraint name we use along with reference partition. Name of the constraint what we used for the foreign key. Now the foreign key is defined on PID, which is a foreign key referencing to ID column of parent table. See, now if we insert data 1, 2, 3 into parent table, 1, 2, 3 into child table, the same 1, 3, 3 is used here. Now if you see the user tab partitions, there are 2 records in child table, 2 records in the parent table. So whatever the record is there in the parent table, corresponding child record is in the same partition. Child table is also partitioned. See, this is partitioned, child table is also partitioned in the same partition. So one record is present in 2007 partition in both the tables. In 2008 parent table has 1, child table has 2. Parent table totally 1, 2, 3 records we have inserted. Sysdate plus 12 means next year 2008 parent table has 1, 2007 2 records. Okay. The child record, say something wrong here. Yeah, the same number of records will be placed in each partition. See, parent has 2 records, child also has 2 records. Here child has 1 record, parent also has 1 record. So automatically the child table will be partitioned based on the parent table. So we are actually partitioning the parent table using reference partition for the foreign key. So automatically the child table will be partitioned. That is the advantage of using reference partition. System partition, as we already know, in hash partition we don't have any control where the records inserted are going, into which partition they are going. We do not know. We can take the control using system partition, creating a table with the 2 partitions P1 and P2, partition by system. Now insert into table, this will throw error because when we are inserting data into system partitioned table, the partition name must be specified. Since we are taking the control to insert data into system partitioned table, the partition name is mandatory while inserting. That means instead of database is taking the decision to which partition the record has to be moved or inserted, the decision has left to the app server, application layer. So the application will decide where it has to insert. So it will append the partition name also into this partition, append this data like that. So now insert into table partition P1, partition P2. We are inserting one record into P1, another record into P2. Now if we query from user tab partitions, P1, P2, it has one row and this also has one row. Let us try to delete from this table using partition name. 0 rows are deleted where ID equal to 1. 1 is present in P1, 1 is not there in P2. We are trying to delete from P2, so 0 rows deleted. update P1, partition P1, set code equal to 2 where ID equal to 2. ID equal to 2, it is in P2, code is also 2. 0 rows, what is this, deleted. It is in P1 we are trying, okay. 2 is not there in P1. It should be updated. So in partition P1, ID 2 is not there, so 0 rows updated. If you select from P1, there is one record. So for delete and update, the partition name is not necessary. Without specifying the partition name also it will work, but if you specify the partition name also it will work. So it is always advisable to specify the partition name so that the operation becomes faster. So apart from this, there is no much benefits of using system partition. Instead of blindly inserting the data into partitions, we are giving the control to the app layer, application layer, to take the control into which partition the data has to be inserted. That is the only advantage. Virtual column partition. Virtual column is added in 11G. We can also partition the table based on virtual column. Creating a table, first char, username is the name where the name of the user will be entered. First character is a column name. This is the virtual column generated always as upper of substring of trim of username 1, 1. We are trimming the username, any spaces before and after, and then taking the substring 1, 1 means one character we are taking, the first character we are taking, that is why the name as first char, and we are converting to uppercase. The given name we are converting, you can remove this trim unnecessarily. Yeah, we are taking the first character of every username entered in uppercase and displaying in the form of first char as virtual column. Now we are partitioning by list based on virtual column. First, this is char. First char is our virtual column. Based on this virtual column, we are doing list partitioning. Partition P1, A to G, P2, H to N, P3, O to U, P4, V to Z. These characters we have specified values. Table is created. Now let us insert. We have inserted some values here. Maybe ID can be different. Okay, like this, some different usernames we have inserted. Now let us query from user tab partitions. So we have P1, P2, P3, P4, 4 partitions, and this is the high value, the values of each partition. And now let us see how many records are there in each partition. Each partition there are 2 records, total 8 records. 1, 2, 3, 4, 5, 6, 7, 8 records we have inserted. The first will be A, first will be B. So A and B. First partition is A to G. Up to G only 2 are there. Next H to N, H, I, 2 are there. Next O to U, O, P, 2 are there. Next V to Z, V, W, 2 are there. Each partition 2 records based on the first character. So accordingly it is stored. So we can also partition the table based on the virtual column. Since it is introduced in 11G, so partitioning based on virtual column also introduced in 11G. But the interval reference partition was missing in 11G, that is added in 12C, as like we have discussed in our earlier example. So we can use interval partition on the parent table, reference partition on the child table. So whenever the parent table is creating a new partition, automatically a new partition will be created for the child table also. In case of interval partition, partitions will be created automatically. So whenever a new partition is created in the parent table, automatically a new partition will be created in the child table. But one restriction is the foreign key column in the child table should not have null values. So we should create not null constraint to avoid inserting null values into foreign key column. By default, foreign key allows null values, but to create a reference partition on the foreign key column, we should not have null values over there. And also we should not have on delete set null clause while defining the foreign key constraint. These are the two main restrictions for reference partition. It can be normal reference partition or interval reference partition. In both the cases, foreign key column should not have null values, and we should not specify on delete set null clause along with foreign key constraint. And there are many other restrictions. See, these cannot be defined on LOB data types, long data types, raw data types, nchar data types, and we cannot go for partitioning on index organized table, external table, clustered table, etc. Apart from this, we can implement all these methods, all these types of partitioning on normal tables. Hope we have covered everything in partition table. It's a very lengthy topic. We have covered almost all the partitions. Let us repeat once again what we have discussed here. Partitioned table, that is table with partitions. One table will be divided into multiple partitions, and each partition can be acting as a separate table for us, so that the maintenance of the data in the partitioned table becomes easier. That is, we can move the data from one partition to non-partitioned table, or we can take the data from non-partitioned table to one partition of the partitioned table. We can delete the data from a partition, we can truncate the data from a partition, we can drop the partition, we can change the name of the partition, we can split the partition. Also, we can add new partitions at the end of the existing partitions of a partitioned table. So all these facilities are available with partitioned table. So whenever we want to search a data in the huge table, if the table is non-partitioned, it will take very long time. If the table is partitioned, the search becomes very fast, because when we have local indexes on the partitioned table, when we search for a specific record, the optimizer will search within that particular partition only, instead of searching in the entire table. So that is why fetching data from partitioned table will be faster than non-partitioned tables. Let us see the types of partitions or methods of partitions we have. Range partition, list partition, hash partition, composite partition, interval partition, reference partition, system partition, virtual column partition, interval reference partition. In this, range partition was the oldest partitioning method, specially created based on number columns only initially. Later on, list partition was added to support character partitioning on character data or varchar data. Next, hash partition was introduced. Irrespective of the data type, we need to partition the table. So we do not specify any column name along with hash partition. We just specify the number of partitions or the partition names also. But when we go for partitioning, hash partitioning, the number of partitions must always be in the power of 2, like 2 to the power 0, 2 to the power 1, 2, 3, 4, like that. That is 1, 2, 4, 8, 16, 32, 64, 128, like this. We can also create hash partitions without following this format. But when we have the number of partitions as a number of 2 to the power of x like this, then the loading of data or the balancing of data segregation will be efficient, and searching will also be efficient in that case. Composite partition, this is to support sub-partitions. Even though we go for partitioning, sometimes one partition will be very huge. Let's take an example of yearly partition. When we have yearly partition, 1 years of data will be there. So that year's data again we need to further partitioned. So in that case, we can further partition the 1 year's data based on monthly partition. This monthly partition becomes as a sub partition. So in this composite partition, there are multiple combinations. Range, this is added in 11G. Before that, this option was not there. Range list means the first one is the primary partition, second one is the sub partition. Range list, range hash, list range, list hash. These three were added in 11G. The list combinations, list as the primary partition and others are sub partitions. Hash combination, hash as the primary partition and others as sub partition is not available